Well, now we are moving on to the next topic, probability distribution table. And the first question has been selected from paper 9709/51 for the session May June 25. And the question we are going to solve is question number 6 of this paper. It says a bag contains 10 marbles, of which 4 are red and 6 are blue. 4 marbles are selected from the bag at random without replacement. The clue word of the question is without replacement. The random variable x denotes the number of blue marbles selected. Show that x is equal probability of x equal to 2 is equal to 3 over 7. That means 4 marbles have been selected one after the other, and we will have to find the probability that 2 marbles are blue. So let's start our solution. First of all, we will write our possible probabilities, possible outcomes. So probability when there are x equal to 2 means there are 2 blue marbles picked up. Let's see what are the possible cases. Suppose the first one was blue. We require 2 blue marbles. So blue, blue, and second 2 are red. This is one of the cases. Then let's suppose the first one is blue, second one is red. First one is blue, second one is red, third one is again blue, and final one is red. Or the third case may be first one is red, then the next two are blue. First one is red, then second two are blue, and final one is again red. Or there may be first one is red, second one is blue, red, then blue, again red, and blue. This is the fourth case. Now fifth case is it may be first two are red. Suppose first two are red, so surely final two are blue. This is the fifth case. Then sixth case may be or first one is blue and final one is also blue. That means there will be 2 red marbles picked in between 2 blues. So these are the total 6 possible cases. Well, now let's write the probability. If the first one is blue, there are total 6 blue marbles out of 10. So it is going to be 6 out of 10 for the first one. Okay. Well, now if second one is also blue, first one is blue, second is also blue, let me mark by this. Second one is also blue. So as there is no replacement, so one marble has been decreased from each of this. So it is going to be 5 over 9 into the third one is red. This one is red. So if there is one red marble picked, then there will be 4 out of there remains only 8 marbles left, because every time one marble is decreased. Then final one is also red. So for red, as one red marble has gone away, so there remains only 3 red marble out of total 7 marbles. Now the question is, what about the rest of the cases? In rest of the cases, if we observe, every time actually the probability is same. Why? Because as there is no there is no replacement, so every time a particular color is decreased. So simply all the rest of the cases are similar to the first case. That means there are 6 such cases. So we will have to multiply by 6. I think you have understood Look, every time if one blue is taken away, the number of blue marble is decreased, as well as the total number of marbles is also decreased. So the cases are all the way same to each other. Hence, if we find our, so our probability is going to be, final probability, if we calculate, it is going to be 7 over, I mean 3 over 7. 3 over 7 shown. Showed. We have shown. They have told us to show that probability of picking up two blue marbles out of 4 is 3 over 7, and we did so. Next one is probability distribution table. Okay, so for probability distribution table, out of 4 there may be no blue marbles picked, or only one blue marbles, two blue marbles, or three blue marbles, or four blue marbles. So let us write the possible cases first. Suppose there is no blue marbles at all. That means probability of x equal to 0 means no blue marbles. That means all 4 are red. Okay. So all 4 are red means probability of red, red, red as well as red. That means if first one is red, there are 4 red marbles. So probability of the first one is 4 over 10. Now as already one marble has been taken away without replacement, so both the total number as well as number of red marble has decreased by 1. So it is 3, then it is 2, it is 1, and every time the total number is also decreased by 1. So 8 and 7. So finally our probability is going to be, when there is no blue marble, it is 24 over 5040, means 1 over 210. 1 over 210. This is one of the cases. Then when there is only one blue marbles picked out of 4, x is equal to 1. So what are the possible cases? It may be first one is blue. First one is blue, rest 3 are red. Okay. Or second one is blue, rest remaining 3 are red. Second one is blue and rest 3 are red. Or there may be the third one is blue. So first two are red, third one is blue, and fourth one is also red. Or there may be final one is blue, first three are red. So red, 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 and final one is blue. Okay, so our probability is going to be equal to, first one is blue, so total number of blue marble is 6, so 6 over 10, and second all rest 3 are red. Okay, so every time it is decreased by 1, 9, 8, and 7. For first blue it is 4, for second blue number of blue marble will be 3, for the third one it will be 2. That is 6, 4, 3, 2. Now as I have already explained that all the probabilities are, all the possible cases are producing same probability, because there is no replacement. Every time one particular color is decreased, at the same time total number of marbles is also decreased by 1. So how many such cases are there? 1, 2, 3, 4. 4 cases. It will be multiplied by 4. So our probability is going to be, if we use our calculator, it is going to be 4 over 35. 4 over 35. Now, next possible case, there may be two blue marbles which has already been obtained. We have already found the probability of picking two blue marble is this. In question number A, we have already solved, so it is 3 over 7. 3 over 7. Then if there are 3 blue marbles, what are the cases? Suppose first 3 are red, I mean blue. First 3 are blue, that means final one is red. Or first 2 are blue, first 2 are blue, then third one is red, fourth one is again blue. This is the second possible case. Or second one is red, rest of them are blue. So this is the third possible case. Or only first one is red, and remaining 3, all the remaining 3 are blue, blue as well as blue. So what are the probability? Probability is going to be first one is blue, that means 6 over 10. 6 over 10, 6 over 10, then 5 over 9, 5 over 9, then 4 over 8, 4 over 8, then the final one is blue, red. So there are 4 red marbles and total number is 7. And how many such possible cases are there when there are 3 red marbles? There are 4 possible cases. So we will multiply by 4. Multiply by 4. So finally our probability is going to be, so it is 8 over 21. 8 over 21. So 8 over 21 is the probability when there are 3 blue marbles. Then the final case, there may be 4 blue marbles. So let us write probability of when there are 4 blue marbles, x equal to 4. So x equal to 4 is actually first, all of them are blue. So probability of blue, again blue and blue. So what is it going to be? First one is 6 over 10, then 5 over 9, 4 over 8, and 3 over 7. So final probability is going to be 1 over 14. 1 over 14. Now we have got all the probability, then let us write them in table. So this is our table. Now we are going to substitute, insert the values. When x is equal to 0, there are total 5 values. So let us see what were the values. The first probability when there was no blue marble was, first probability was 1 over 210. Second one was when there was only one blue marble, there were 4 over 35. Third one was 3 over 7. Then fourth probability was 8 over 21, and final one is 1 over 14. So let us substitute them. First one is 1 over, when x is 0, then probability is 1 over 1 or 2 or 10. So first one is 1 over 10, 1 over 210, 210 we are living in simplest fraction. Then the second one is 4 over 35, 4 over 35. Then when there were 2 blue marbles, it was 3 over 7. 3 over 7. When there were 3 blue marbles, it was 8 over 21. Then when there were 4 blue marbles, it was 1 over 40. When there are 4 blue marbles picked, the probability was 1 over 40. And there is no more, there cannot be more than 4 blue marbles because only 4 marbles were picked up in total. So that is what the probability distribution table of this question. Let's see the next question. The next question has been chosen from paper 52, which says, this is the first question of the paper 52. It says Rachel has 3 coins. The first coin is biased so that the probability of obtaining a head when it is thrown is 1/3. The second coin is also biased so that the probability of obtaining a head when it is thrown is 1/4. The third coin is fair. Rachel throws the 3 coins at the same time. The random variable x is the number of tails that she obtains. It is all about tails. Draw up the probability distribution table for x. Let me erase this unnecessary writing. Let us write the individual probability of each of the coins. For the if there is h obtained, the probabilities are 1/3, 1/4, 1/3 for the first coin. For the second coin, it is 1/4, and for the third coin, it is fair, so it will be half. Okay, 1/3, 1/4, and half. Then for obtaining tail individually, it is 2/3 for the first coin, then 3/4 for the second coin, and since the third one is fair, so it is half. Well, now she has thrown all 3 coins together, and they have told us to find that number of tails. Okay, drop the probability distribution table. So after throwing this, there may be no tails. Suppose there is no tails, that means all of them are what? Head. So first one is head, second one is also head, third one is also head. So what will it the probability be? The all heads, 1/3 into 1/4 into half, 1/3 into 1/4 into half. So finally our probability of obtaining no head, no tail, is 1 over 24. 1 over 24, first one. Now if he obtains only one tail out of 3, so what are the possibility? Let's see. First one is tail. Okay, first one is tail, second and third are head. Or second one is tail, second one is tail, so first and third one is head. Second one is tail, and first and last one is head. Or he might obtain the final one is tail and first two are head. So first two are head and final one is tail. So these are the 3 possible cases for obtaining one head. So if the first one is tail, it is 2 over 3 probability. Then rest 2 are head. So 1 over 4 as well as 1 over 2. If first one is head, then the probability is 1/3, and for the second tail it is 3 over 4, and for the final head it is half. Well, if the first two are heads, then it is going to be 1/3 into 1/4, and final one is fair, so it is going to be half. So finally our probability is going to be, denominator is 24 in each case. So this is 2, 2, 3, 5, 5 over 6. 6 over 24 means 1 over 4. Let me write just beside this, equal to 1 over 4. Then the third possible case is he might obtain 2 tails. He might obtain 2 tails. If 2 tails are obtained, what are the possible cases? Suppose first 2 are tail. Okay, first 2 are tail, third one is head. Or first one is tail, second one is head, and third one is also tail. Third one is tail. Or first one is head and last 2 are tail. So these are the possible 3 cases when there are 2 tails. So let us write the probabilities. For first tail, probability is 2 over 3 and rest 2 are heads. So 1 over 4 and 1 over 2. For the second case, if first one is tail, it is 2 over 3. 2 over 3. For the second head, it is 1 over 4, and final one is actually non-biased, I mean fair, so it is always half. Plus, if first one is head, it is 1 over 3 and rest 2 are tail, so 3 over 4 and half. Then if we use our calculator, we will get, it is 24, so 2 plus 2, 4, 4 plus 3, 7. It is going to be, sorry, we made a mistake over here. Second tail is actually 3 over 4, so it is 3 over 4. So 6, 6 plus 2, 8, 8 plus 3, 11. So 11 over 24. Our probability is 11 over 24. Okay. Now, a question may arise in your mind that in the previous solution, we didn't find individual probabilities. We have just multiplied by 3 and 4. Remember, that one was fair and without replacement. For without replacement, it was always uniform. But in this case, the all 3 coins are not of same probability. That means they are biased in different with different probability. That's why you cannot just finding one probability then multiplying by 2 or 3. It will not be logical. So please don't get confused. In this case, they are biased and the probabilities are not uniform. So let's see the third one. When probability of, when there are 3 tails. So if all 3 are tails, it is 2 over 3 and 3 over 4 as well as 1 over 2 means half. So it is going to be 6 over 24 means 1 over 6. Sorry, 1 over 4. So these are the 4 possible cases of this probability. Okay. Now we will write the probability distribution table. So our probability distribution table is ready. Now insert the information. The first probability was 1 over 24. Second one was 1 over 4. Third one is 11 over 24 and then 1 over 4. So let us write 1 over, when x is 0, then our probability is 1 over 24. 1 over 24. So these are the probabilities over here. That is when when x is 0, our probability is 1 over 24. When there is only one tail, then probability is 1 over 4. When there are 2 tails obtained, then probability is 11 over 24 and final one is 1 over 4. So that's all about the probability distribution table of this given scenario. Let's see the next question. The next question has been selected from paper 9709/55 for the session May June 25, and the first question belongs to the topic we are discussing now. Two fair six-sided dice with faces labeled 1, 2, 3, 4, 5, 6 are thrown. The two scores are noted. The random variable x is defined as follows. If the scores are equal, then x is equal to 0. If the scores are not equal, then x is the larger score. Okay. So as both of the dice are fair, so we will have to first of all draw the scenario that. So these are the table we can prepare the possible cases. Well, if both of it is written, if the both the scores are same, then it is 0. Okay. So let us see, from the first dice there is 1, and for the second dice also 1, so it is 0. So is over here, first dice is showing 2, second dice is also showing 2, 0. Then this is 0, 4 minus 4, 0. Then 5 minus 5, 0, and 6 minus 6, it is 0. Then the difference, 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4, and 6 minus 1 is 5. Then 2 minus 1 is 1, then 3 minus 1 is 2, 4 minus 1 is 3, 4 as well as 5. Okay. Then 3 minus 2 is 1, 2, 3, 4. Then this is 3 minus 3 is 0. Then 4 minus 3 is 1, 2 as well as 3. Then 1 as well as 2. Then 6 minus 5 is 1. Well, then 2 minus 2 is 0. But 2 minus 3 is 1. Then 2, 3 as well as 4. Then it is 1, 2, 3. This is 1, 2, and that is, this 2 should be over here. Okay. So these are the possible outcomes when both the dice are thrown. Finally, we made a mistake. Actually, it should be 4. 2 will be over in this upper row, then it will be 1. Okay. So total there are 36 outcomes we know. Now our probability distribution table. Okay. Let us draw the table. This is our probability distribution table. Now we are going to insert. There are there are total 6 digits starting from 0 until 5. Okay. So now we are going to just substitute the values. Let us see how many zeros are there. The 1, 0, 1, 2, 3, 4, 5, 6. Total outcome is 36. Out of 36, there are 6 zeros. That is 1 over 6. So first one is 1 over 6. 1 over 6. Now how many ones are there? Let us count the ones. How many ones are there? Number of ones is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 9 over 36. That means 1 over 4. 9 over, sorry, is it 9? Or should it be 10? Let us count once again. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, there are 10. So 10 over 36 means 5 over 18. 5 over 18. Then the, how many 2's are there? Let us see. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 2's. So 8 out of 36 means 2 over 9. 2 over 9. Then how many 3s are there? 1, 2, 3, 4, 5, 6. So it is 1 over 6. 1 over 6. Then how many 4s are there? 1, 2, then 3 and 4. 4 4s are there. So it will be 1 over 9. 1 over 9. Then how many 5s are there? 1 5 and then 2 5. There are only 2 5s. 2 5. So it is 2 over 36 means 1 over 18. 1 over 18. So that's all about our probability distribution table of these two coins. Let's see the next question. Now I think this is the final question of this session.